Early here. I think we got everybody. They closed the doors on me, so there we go. Thanks everybody for coming to my talk. I'm Andrew Plunkett, and I'm going to be talking about automating Yara rule quality assurance. Is there anybody in the room who doesn't know what Yara is? We're all security people. Oh, we got one guy who doesn't. No, he says he does know. He's just messing with me. Yeah, we're all security people, so we've probably all heard of Yara. In a lot of our jobs, we have to use Yara rules. And this was a project that I took up to kind of manage our current rule set at where I work. So hopefully you guys get some use out of this talk. Who am I? The typical who am I? I'm a technical lackey security guy at Industrial Megacorp. I don't know if you guys watch Mr. Robot, but I think I work for Evil Corp. I'm not. Whenever I watch the show, I think they're talking about my company, but I'm really not sure. I'm a former pen tester, red team guy. I did that for a few years, and now I'm one of the good guys on the blue team. I try and stop the red team, and usually don't do very well at it. Focus on the OT side of things lately. I've been getting interested in that. My company does industrial things, so that gives me the opportunity to also do industrial things, which is kind of cool. And I'm from Cincinnati, which is way cooler than Louisville. So yeah. All right, all my Cincinnati people. What is Yara? That's a picture of Victor Alvarez, the guy who started the Yara project. It's been around since about 2008. It's like grep for raw data. You can use it to find anything. I was going to put like what you could find, and then I realized you can actually use it to find anything because it scans all data for anything that you want to look for. So it's byte strings. Byte strings of specific range and offsets. It allows regular expressions, all the fun regex stuff. And then it's got modules. Those are kind of new. They're really useful. They kind of understand certain things about executable files so that you don't have to write everything out. It kind of already understands certain things about what you're looking for. And then the true power comes from the complex conditional statements at the end. So you're not only searching for things, but you can tell it to search for things in certain places and other things not in certain places before you create an alert. It's optimized for incredibly fast pattern matching. That's really based on how it creates the rule set. It does a bunch of nice things, so your rule set is optimized. So what it's searching for is really well done. And it's useful for looking for things. And as security people, we tend to look for things. It's like our main jobs is essentially to find bad. So we look for things all the time. So there are a lot of reasons to use Yara. This is an example Yara rule. I think everybody kind of knows what we're looking for, but this is the general idea. You have rule, name, some curly brackets, metadata about the rule. That's actually optional. You don't have to put anything in there, but good rules generally have at least who wrote it, a contact for if you want to update the rule, and then usually a reference to a write-up from where the rule came from or the malware sample they're dealing with. Sometimes it's got hashes in there and things like that. And then you got strings, which is really what you're looking for. Strings it's weird. That's kind of like it's always there. It's called strings. Even if you're looking for hex, they still call it strings. It's still in the strings section. I don't know why it's like that, but I guess that's just how it's been always. And then you got your conditional at the end. This is a very simple conditional, but basically it's saying find one of any of those strings. So cert $, and as you can see, the string variable names are cert 1, 2, and 3. So it's basically saying any of these cert files, at least one of them. There's a lot of useful reasons for Yara. We use it for a lot of different things where I currently work. We have a tool that scans endpoints. And this is really why I came upon this project, is because that's in production. It scans our workstations. We really can't screw with our workstations. Our users will get really mad if we blue screen or take up too much CPU. We get flacked. People already don't like security guys. We don't need to get worse about it. We have it in our sandbox, so everybody's got a sandbox now. You run samples through. You can implement Yara in your sandbox to tell you what alerts hit on the sample you just ran through it. So if you got rules to identify certain samples. You run a sample through your sandbox, it'll basically spit out, hey, this is this, and we have rules for it, and this is the write-up for it. So if you need more information. Virus Total, Retro Hunt, if you got Virus Total Intelligence, which you probably should, it lets you essentially use Yara signatures to search for past samples, previous samples, and current future samples as well. And Victor Alvarez actually works for Virus Total now. They use Yara in the back end to do that. That's why you can use Yara rules to search Virus Totals, because the guy who wrote Yara works for Virus Total now. And good on him for doing that. VirusTotal is actually a Google company now, so I'm sure he makes bank. You can use Yara to do email scanning. We actually have a tool, so if it gets past our commercial product, we also run Yara rules on all emails and attachments that come in for Intel that we have developed in-house. Malware analysis, if you're doing manual analysis, you can always use Yara rules. I really don't find it very useful because usually if I'm doing manual analysis because I don't have a rule that already told me what it was, but you can create rules from doing manual analysis, which is nice. And then there's some companies out there that literally run Yara as an IDS. There's actually a company in Cincinnati that's doing a really great job with it, but essentially is an IDS that runs Yara rules over network captures. And they're doing a really great job with it. I won't mention their name, but you can look them up. So there's some issues with collecting Yara rules. Rules take time to create. I personally don't really like reverse engineering, and that's me right there in front of the giant chalkboard going, whenever I have to reverse engineer something, I don't really like to do it, and I generally start thinking about other things like Samurai Jack and shit. So public rules are available though. That's the beauty of it. There's a lot of people out there who like to write Yara rules, and I can just basically take theirs. They write a nice write-up on a malware sample. I don't have to do my own reverse engineering. I can take their rules. Great. Now I don't have to do it. My life's sweet. I can watch Samurai Jack. There's a problem with that. You really should not put user-supplied input straight into production. If you're accepting someone's public rule, it's not, you didn't write it, you don't know the quality of that rule, you don't know if it's going to work with your tools, you really can't put it into production, especially in a production environment where, people are creating things and shop floors going down, it's like millions of dollars and you get fired for it. So you really can't take user-supplied input and just throw it straight into production, which is really the whole point of this talk. We had to create some way to do quality assurance on user-supplied rules so we didn't have to reverse engineer things all day. So there's some issues with public rules. These are the general issues that we have when dealing with public rules and trying to put them into our tool. So you have multiple different collections of rules. Do they overlap? Are the different collections of rules looking for the exact same thing? So one of the things you have to do is deduplicate the collections of rules. If you're pulling from 4 different collections of rules, you have to deduplicate them all so that you're only looking for one thing at a time. Do they work with our tools? The version of Yara, we actually use it with a tool that we specifically wrote at my company, so we have to basically make sure that the rule works with our version of Yara. This is actually a really simple problem to overcome because our QA uses our tool. So, and anybody can do that. And really this is a versioning issue with Yara. If you're using an old version of Yara, you have to make sure that you're QAing with your version of Yara because as newer features are implemented into Yara, newer rules won't work with your old version. You have to make sure that everything works right. This one was kind of funny. Do they even compile? Because yes, some people upload things to public repositories that don't even compile. The rule literally doesn't even work with Yara. So you got to make sure that it actually will compile and run. And then this one was kind of important for us. I used to be an analyst, so I don't like false positives. Anybody who's waded through false positives day in and day out don't like false positives. So we had to develop a way to kind of at least get an idea of what kind of false positive rate we're going to deal with when dealing with these rules. And then is the rule written well and efficiently? This was another huge thing for our tool. We scan our endpoints with a whole lot of rules, and we can't open it up to the whole CPU. Our users will complain at us, so we have to throttle it. So if a rule is not written efficiently, it will slow down the length of the whole scan, and our scans will never complete, or it will take a month and a half to complete, and we really can't have that. That was another reason why we had to do this is some rules will compile, and they'll have great false positives rate, but they have super complicated regular expressions, and they'll just take forever to run with our tool. So we had to make sure that they will at least run in a reasonable amount of time. So now we're going to go over the steps to automating Yara QA, just kind of simple stuff. Really nothing groundbreaking, but it was after trying to do this myself, these are the steps that I had to take to automate the QA. So the first thing is you need a server that does this and only this. And it can't really do anything else because you're doing performance testing on the length of time it takes for a rule to run. So it has to be uniform across scans with a rule. So you can't really have anything else running or else your times are going to be off. So it doesn't even have to be a big server. It can be really small as long as the scans sequentially are uniform on the same piece of hardware so that the times will all end up being the same. So it doesn't need to be big. It can be, a really small VM if you really want. But yeah, don't do anything else on it. you need a way of automating the updating of all of your collections of rules. You don't really want to pull repos all the time. It's really simple. Just get a Git account, use SSH keys so that you can automate the pulling of these repos on a daily basis or however you want to do it. Doesn't matter. We pull once a day. And then you use bash and cron. Just use a bash script, put it in your cron tab, and pull these repos every day. Super simple. This was the easy part. This took me like 10 minutes. No problem. And I love that picture of cron. So I got to admit, a lot of my slides I couldn't really come up with a picture for. So I just Googled like something on that slide, and there's some really weird pictures that came up. So some of my slides have some really weird pictures in them. Just going to go ahead and say that. So copy all the files into a new directory. Since a lot of these collections of rules actually share rules, there'll be an Intel report out there that's really big, and one repo of rules will pick up that rule and put it in, and another repo of rule will see the same Intel report and pull that rule in as well. So the first thing you got to do is take all the rules from all the repos that you updated, copy them to a new directory. The problem is you're going to have name collisions. So I had to write rules that basically say, hey, does this file already exist with its name in this directory? If it does, add a 1 to the end, add a 2 to the end, blah, blah, blah. Super simple. And when I searched for name collisions, I got this nice graph talking about how, I guess, we have really strange baby names now, because in a long time ago you would get name collisions when naming babies. So the other stuff is really simple. There was a bunch of file maintenance stuff that we had to do. It's user-supplied input. You never really know what you're going to get. And some things break when you're trying to script weird file names. So first thing you had to do is take spaces out of file names. I think everybody in this room hates spaces in file names. Just being tech guys, it screws up things. For as long as I can remember, I always put underscores instead of spaces in my file names. But that's the first thing I had to do, was basically remove spaces from file names. It kind of screwed up the rest of my scripts as time went on. Delete empty files also screws up my scripts, and yes, there were empty files in these repos. I don't know how they got there. I don't know why they're not there anymore, but they're in there. And then you have to remove duplicates using hashes. This was one of the things where, even if they had the same name, I basically just renamed them to make sure that I wasn't actually, even if a rule has the same name, that it actually has different content. So I didn't want to just remove them based on file name. I wanted to actually take a hash of each rule and then remove duplicates that way. The beauty is that after I did this once, I reused this code a couple times, because you'll find out that we have to remove duplicates a couple different times throughout the steps. So this was actually one of the hardest parts of it all, is a rule file can have multiple rules in it. And for performance testing, you really need to break out each one of those rules separately. You need to take that rule file that has multiple rules in it, rip out each rule separately, and put it in its own file so that you can do performance testing based on each individual rule. Because if you have a rules file and one rule in it is bad, it will ruin the whole scan. If you try and scan that whole file with the Yara rule, it's just going to ruin the whole performance testing. Nobody's going to know what's what. So I had to break them out separately. The regex for this was kind of complicated. It took me almost a day and a half just to come up with this regex, because it was, I don't know, it had to be greedy, it had to not be greedy. There was user-supplied input, again, kind of screwed me on this one, because most people write rules a certain way, but some people write them really weird, and it broke my whole regex. I had to start over from scratch. And this is Zoolander. I don't know where the hell this picture came from, but I had to put it in there. When I found this picture, I was like, whatever. Regex tool for ants, I get it. So you had to create a separate rule file for each rule. So after you use your regex to rip out each rule individually, you got to put them in its own file, and then put all those into a new directory. The name of the file is the name of the rule, so each rule has its own name. I just basically said, hey, we'll make the name of the file the actual name of the rule in that file, and then avoid name collisions. And then Yara does a weird thing now with modules. So they have the PE module, which is really useful. A lot of people use the PE module now. There's also the hash module, the math module, elf module. There's cuckoo module. We didn't use the cuckoo one, but I didn't want to go in and try and parse what module each rule used. So I did a really thing. I imported every module into every rule. If it doesn't use it, who cares? But it was really just an easy way. All I did is prepend to the file in every import, right? So it was 4 of them. I just imported all 4 imports into every single rule. Easy peasy. And that was an image that came up when I searched the word for single in Google, which I thought was funny. So now that we've cleaned everything up, we can actually run the freaking test. So we got our whole environment laid out. Everything is set up. So now we can run the test. what you want for this test is a couple gigs of known good files. There's also a guy on the Yara exchange actually came up with like 9 gigs of good strings. You could probably also use that, which is literally just strings that are found in commonly on Windows systems. But we also have a whole giant repo of known good EXEs. You can make them yourself. It's not hard. You know, download from CNET or whatever. Just things that you know are good that you can run your tools against. This is your false positive repo. Yeah, don't use 4chan or something. You'll screw up. Yeah, or CNET. All right. But basically, you just want a good set of known stuff so that if your rules create an alert on this known good stuff, it's not a good rule. It's going to go wild in your environment and create mass false positives. So you just want known good things to scan against. So the first thing we do is hash the rule. This is so you don't deduplicate effort. It's already gone through all of our initial QA, so you know that this rule is pretty much you're going to want to run it. So the first thing you do is hash it. That way, when you run the QA the next time, if you just check the hash, say, have I already ran QA on this hash? If I have, then skip it. And what it essentially does is that the first time you run this, you will have like thousands of rules. Every time after that, you only have like 4 or 5. You don't need to run all 1,000 rules again every day. You really just need to run those 4 or 5, and so we just do it based off hashes. The first thing you do is take the hash. Check for compilation errors. This is really easy. It fails out almost immediately. The scan, it literally takes like 0.15 seconds or something like that to basically say, this rule is garbage, I can't use it. Super simple. Throw that rule out. So check for false positives. Essentially run it against your known good set. If you get alerts back, count the number of alerts, put it in the file, say you probably don't want to use this rule because it alerts on good data, worthless rule. And then the time to scan. This is kind of tricky. I can't say I did this actually the best way possible, but it works. Essentially, I just, in Python, start a timer, call a sub-process to call Yara with my rule, and then stop the timer once it's completed. And then take the delta of that, and that's how much time elapsed. You can do it like system time, and there's a bunch of different ways to calculate the time it took to run, but I just did it kind of the easiest way, which works perfectly for what we're doing. I didn't really need to get too technical on it, and it works fine. So after running all these tests, you end up with a CSV that looks kind of like what I put there. You have your hash, you have your exit code, you have the number of alerts, you have the total time elapsed, and then these last 3 things are really important, and they actually go on to this, my last bullet point there, is you need a way for your scanning tool that you're using these rules for to also affect your rule QA. So you use these rules in production, you need a way to track how often these rules are false positive or not. This way you can tune your rules. If you have a rule that's false positive all the time, you want to basically put it back into your production rules file to basically say, skip this from now on. It passed our automated QA, but in reality, in production, this rule is garbage. So it passed our automated way, but through manual analysis, this rule's been turned off. So that's really important, or else you get rules that hit all the time, but it will always pass our QA. And then essentially you come up with one conditional at the end that basically says if it passed all these tests, move it to a folder. This folder is now production. Kind of simple and easy. And then like I just said, you got to have a way to track true positives and false positives for a rule. This is kind of one of the things that was really important. This wasn't built into our tool originally, but we found out that it's really important to do that as time goes on. I was going to do a demo, but I got to admit the demo would have been pretty lame. It would have been me hitting enter on a command line and then waiting for a CSV to output. You guys wouldn't really see it. And the CSV output would have looked just like this. But I also forgot my token to log into the VPN of my work, so I can't actually do it. I found that out last night. I wasn't about to go home and get it. So I guess we could have done that. I could have asked some of my Cincinnati guys for their VPN, but yeah, where can you find the code? This was not technically done through my work, essentially because we didn't want to get lawyers involved with trying to open source it. My boss basically said, "Go ahead and open source it, but won't tell anybody." And I was like, "All right, fine." I did it on my personal time. If everybody asks and they don't watch this, I did it all on my personal time, and I'm letting my work use the code. Yeah. And there's a little disclaimer to go along with this. I'm not a full-time developer. I don't write C++ or something. This is all done in Python. And when going through this was almost straight like, I had to Stack Overflow question like every single step of this process, and then rip the code out, mangle it together into what I currently have and work. So it's really not good, good looking, but it works, and it works perfectly fine. So hopefully people who maintain large sets of Yara rules can use this code to do it themselves, and I really hope you get some benefit out of it. It saves us a lot of time. I don't have to do this as part of my daily job anymore. It basically just runs by itself. So lovely. I think I crushed time. I'm like super early. So I guess, does anybody have any questions about any of this? I can't really talk about it much more because it's pretty straightforward, and I just have code to share. So does anybody have any, and that's me watching Samurai Jack now that I don't have to reverse engineer stuff all day. Hey man, what's up? Quality assurance, man. You must not be in the development world long, man. I tried to call the project Yaraka, like Yara QA, all is one word, but the guys I work with basically said that was stupid, and they said that you should just call it Yara. Yeah, but so, what's up, man? Actually, I gotta admit, the Yara documentation is awesome. There's a read the manual for Yara that is really well done, and it's updated with each release, so it's not one of those things where it's like outdated or anything. It's really good. And then there's a guy who runs a tool much like ours, but he sells it, and he's in Germany, and he wrote a really good manual for how to write good performance for rules, like regexes to avoid common mistakes to make in rules, and that's kind of a supplement to the read the memo. I forget the guy, what's his name? I'll tell you what, I'll put a link to it in my GitHub so anybody can read it, but it's a really good memo that kind of go along with the manual about common pitfalls to avoid when writing Yara rules. So. What's up, man? What's my? You know what's funny is I was going to put that in there. I don't have a cool handle, man. I'm just Andrew Plunkett, I'm just an everyday guy, man. No lead hacker here. At least not a handle I'm going to give you. I don't want the NSA, What's up, man? Sure. They asked me for my Twitter, and I don't have one, man. So. Oh, okay, Mike, I do have one. I just don't use it, so it's kind of pointless. Yeah, probably should. Anybody else have any questions? Okay, well, thanks for coming to my talk. I'll give you guys some time back to go eat some lunch or something.